In this interprofessional assignment, I will be looking at the unregulated and informal recycling of used lead-acid batteries. Through this presentation, I will be covering a background introduction on used lead-acid batteries and its improper recycling process, an introduction to some of the environmental risks that this process can pose, cross-discipline approaches from three professionals of different fields, and a short summary and simple framework for how some of these approaches can be combined. Firstly, one of the most traditional and ubiquitous types of rechargeable battery is the lead-acid battery, or LAB. Over 70% of the world's rechargeable batteries come from this type of battery, while over half of this LAB use stems from automobiles. LABs are quite expensive to acquire and quite expensive to dispose of properly. And at the same time, their component parts and raw materials are quite valuable. Therefore, many communities and individuals in lower and middle income countries will resort to the unregulated recycling of used LABs on the grounds of both accessibility and financial prospects. This process produces myriad toxic chemicals, which then harm the health of an environment, workplace, and larger community population. The most abundant toxin released by the used LAB recycling process is lead, a human carcinogen, which is then dispersed by fumes into the environment due to poor environmental controls in the immediate recycling workspace. Populations are then exposed through various pathways, and a very common risk associated is lead poisoning in children. In many cases, this can lead to long-term cognitive and behavioral defects, and in the most serious cases, this can lead to chronic respiratory and neurological conditions, or even death. The three professionals interviewed for this project are Dong Fu, an urban architect based in Beijing, Bill Roth, a child and family protection attorney based in California, and Kim S., who asked that her full name not be shared, an environmental policy advocate based in Colorado. Mr. Fu shares some of his expertise and experience from the nation of China, a nation where U-Labs have been prevalent throughout its history. However, in recent years, some of China's efforts in implementing elements such as smart design, as well as large and rapid-scale transition to the ubiquity of electric vehicles, has mitigated some of these negative effects. However, it should be noted that much of China's approaches have focused more on adaptation and mitigation as opposed to prevention entirely. China is a very polluted country, a lot of which may very well be irreversible, and a lot of this pollution does come from automobiles and lead-acid batteries. From the design-specific perspective, Mr. Fu notes that a lot of architectural discussion will be related to sustainable development, green ecology, smart design, and green architecture, often called arcology, such as the utilization of prefabricated building components, incorporation of green elements and natural elements such as trees, sponge cities, passive solar energy, among other methods. What may be related to batteries specifically is that many current building design regulations require that part of the parking spaces, such as 10 to 20% in certain cities, must be equipped with charging piles, which means that the city encourages the development and further advancement of the electric vehicle industry through adjustment of building design regulations. This is a positive future trend and something that China has done more outstandingly than some even more developed nations, such as the United States. Mr. Fu does, although, question the effectiveness of smart design in lower middle-income countries where such a large-scale transition may be less possible. He also notes that it may be important in some of these nations where financial prospects are less accessible, that some of these more serious issues can only be better solved by relying on developed countries to provide financial and technical support for the upgrading of relevant enterprises, a sentiment echoed by some of the other professionals in this assignment. From the perspective of law, Mr. Roth, a supervisor representing the Department of Children and Family Services, states that regulating requires assistance from wealthier countries to help make the process safer and economically viable, a sentiment echoed by Mr. Dong's earlier stated thoughts. Education, he notes, is also an important step to proper recycling, but is not sufficient on its own. Education must therefore be paired with significant changes to regulation and enforcement. Two particular methods that he notes may be helpful is to build in a cost to the purchase of batteries, and therefore buyers can receive a refund on the substantial recycling charge that they may later face. Another method would be to implement extensive buyback programs, wherein batteries could be sold to recycling plants who could properly recycle. This framework would need to be economically advantageous to the buyer for it to be effective in the long term. Mr. Roth also considers some questions of ethics and unintended consequences. For instance, increased regulation may also see an increase in underground recycling, as well as serious impact on the ability of unregulated recyclers to support both themselves and their families. This can also see a potential increase in crime, as individuals and communities may turn to alternative methods for financial support. From the perspective of advocacy, Kim S., an advocacy and outreach chair in Colorado, notes that the effects of serious problems such as used lead-acid battery recycling are not often felt by domestic U.S. individuals, and therefore it can be difficult to enable, encourage, and rally a call for action from powerful international parties and other powerful nations. And therefore, complementing Mr. Roth's perspective, education is still a key method on this domestic front. From the stem of the ULAB issue and others like it, U.S.-based advocates hope to see an increased incorporation of international study and analysis into a standardized American curriculum. Kim notes that this is a long-term solution, but this generation and the next could help to kickstart gradual change towards a greater global understanding of human rights and environmental issues related to crises such as ULAB recycling. Here is a simple framework combining these three approaches. At the top, we can see the approach with the shortest term potential benefit, which is the potential incorporation of arcology and elements of smart design into environments and immediate workspaces where ULAB recycling may be present. This can help to reduce the dispersion of lead fumes, as well as potentially capture some of these released fumes, therefore mitigating its impact on the immediate community and environment. Secondly, we can see the medium-length approach, which is to implement extensive programs such as buyback programs, which can start to slowly shift the financial incentive at the core of the ULAB crisis. Finally, at the bottom, we see the approach with the potential for the longest term benefit. Increase in education and potential changes or additions to a domestic American curriculum can help on our American domestic front to better educate us on international human rights crises such as improper ULAB recycling and move towards greater global cooperation and solution. And these are my cited works.